Hi, welcome to this new tutorial. I was watching the video that Andrew Price sent about the power lines in geometry nodes, and some people asked me in the Discord how we can do this. So I'm going to share with you how I replicated this setup. As you can see, with just extruding here the curve, we can create new instances that are connected by cables, and we can control a bit the tilt here. We could add more controls, but we have a seed, variation on the height of the different power lines, and also we can control the height of each instance. So if you're curious about how this works, I'm going to explain that to you. Let's get started. This time we are not going to start with a cube, we are going to add a Bezier curve. I will enter edit mode and I will scale to 0 the handles so I can extrude without the curve. And now with E, you can just extrude a new segment. Okay, so we have our line. We're going to go to the Geometry Nodes tab and we create a new Geometry Node setup. At this point, I'm using the 3.0 alpha from 19th September. So this is a bit a mess now, but so you can have an idea of the version I'm using. Okay, to start, we have, at this point, we have a line. We have two control points. We can see on the viewer. Here we have the two control points and also the spline. And the first thing I want to do is to rotate our points. So when I instance something, they will have the rotation of these points already. To do that, we will add an attribute randomize node. And we want to randomize the rotation. We will change this to vector. At this point, I will add something to instance so we can see what we are doing. We're going to make a simpler version so you can know the mechanics, but we don't lose time in details. You can add those details later. So I'm going to use a cylinder, point instance node. Now we have the option to change the type of object here to geometry, so we can use things from inside the setup. So we can plug this, for example. Here we have a random rotation between 0 and 1 in all axes, that's why we see this. If we change everything to 0, there's no rotation. Now we will change this to look more like the posts that hold the lines. Here this is optional, but you can add an attribute fill and replace the shade smooth to a value of 1. We will use a combine so we can access the three values individually. There's something else that we have to do here. We will expose this to be able to control the height. Now we can control the height from outside, from here. And to compensate, because this is scaling from the center, so we need to compensate that. We will add a transform node here, also a math node. And we will make our height divided by 2 or multiplied by 0.5. And we need a combine again here. I would love to have this, like, double click here and you change this to 3 different inputs and you double click again and you have your single purple input. It will be simpler than adding constantly these combines. Okay, so we are going to use this here to move it half the size up. And that way, now when we change the height, it will grow from the bottom, we can say. We will leave it at 2 for the moment. I want to try and see what we are going to do with the rotation here, the tilt. Here we can already see that if we extrude this with E in edit mode, we will instantly get a third column here, a third post. We'll connect to the minimum and also to the maximum to define the rotations. We can see that if we change X, it rotates around the X, and that's something I want. The rotation Y also, it's important, forward and back. But at this point, we don't need rotation on Z axis, so I'm going to leave it for now. I will expose one. This value will be our tilt amount. We will use the same value on Y. And for the maximum, we are going to change this. This will be our maximum. And for the minimum, I will duplicate this and I will multiply this by -1. This way we have negative and positive tilt on each axis. We connect this to X and Y. And we connect this here. So now as we add value to this tilt, we have a random value for each. If we add more, we can see it better. We can also expose the seed. And now if we change the seed, we have different random values for each instance. Okay, so we expose the seed and we can continue. Now I want to add the part that holds the different cables there, like the T that we have here. I will use just a cube in this case. I will later use this cube for another thing, so I will instance it on a separate node. I will not join before the instancing. So we will be instancing on the same control points, and then we will join them. For now we have this that looks like more like a hammer, so we are going to make a few changes here, and we are also going to move it with a translate. For now we will adjust the size of this. It's thinner than the post. We could take the width or the diameter of the post and then multiply by 0.8, but I'm not going to lose time with things that we already saw. You can later optimize the setup if you want. Something like this, it's fine. And now we want to push it up to something that will be the height of our post, but we will subtract an amount. So we are going to use the same value here. I will duplicate this combine. I will connect this here and this here. We can minimize this for now. And here we will subtract some value from this. It will be the distance from top. Now what we are going to do is what will be later the 4 different cables that we have on top. To be able to do this, we are going to use the same Bezier curve that we have on the bottom, and we are going to duplicate it 4 times. As I always say, there's a lot of ways to do this, but we have to pick one. So I'm going to use 4 different transforms in this case. Just to see what we are doing, I'm going to connect this here. We will connect this here to the join geometry. And for now we can see anything because it's on the same spot. We will translate it 0.2 on Y. Ctrl-Shift-T to duplicate, maintaining the connections. This one will be 0.4. We also connect this to see what's going on. Ctrl-Shift-D and Ctrl-Shift-D again. And now we are going to minus 0.2 and minus 0.4. Now with Shift and dragging the right mouse button, we can join this. Now we connect these two. And here you have what will be the base of our power cables. Now we can disconnect everything here. We will use another join geometry to join everything here, the 4 different curves. If you want, you can expose this value to control the distance from the top of this. Let's do this already. And we can name this point T. So that's the height of this. And we will use this value again because I want to move these lines to the same height of this T. So that's exactly what we need. So to do this, we will use an attribute vector math because we need it to be a vector, not just a value, because we are using the position here. We connect this, and I will add to the current position that they have a vector value that's exactly the same that it's translating the T point. So we use this to move this to some height, and we will use the same value to move the cables. There. Okay, that's looking good for now. And to this result, I will name it position 2. And now I want that when we tilt these posts, the cable that is going up also rotates, but with the center on the bottom of the post. Otherwise, it will be a disaster. For now, we will leave this at 0. I will also limit this to minimum 0. Here we will use an attribute vector rotate. And the vector that I want to rotate, it's the one we created. That's why we don't replace the position here, because we are going to rotate it first. So we will rotate position 2. That's the top position, we can say. Let's join this so we can see what we are doing, and we can have the list of attributes here. So position 2 is the same position that we have here, but at the height of the T. We still cannot see that because we didn't replace the position. We just created an attribute. And for the center of that rotation, we don't want a vector, any vector. We want an attribute. And that attribute will be position. That's the initial position on the floor, we can say. And we don't want a different center for each one. We want them to have the same center, the original curve that we have in the middle. Or we will have everything going wrong because they are rotating with different centers. So to do that, before we do the transformations here, that everything is on the middle, because they are exact copies, we will create a copy of the position and we will save it with an attribute name. And since we didn't move them yet, the position will be the one on the middle. My objective here is to copy the attribute, but since there's no copy attribute node, we will just add 0 and save it with another name. And in this case, we are going to name it position 1. We will change the type of rotation here to Euler instead of angle. And our rotation will be also an attribute. So what's the rotation we are going to use? The same that we defined here. So they match the rotation of the points so that the posts have the same rotation that our cables. So we choose rotation here. And I will show you what happens if I don't use this attribute. We set the result as position. Everything looks fine. The cables are in place, but if we tilt this, it's not that easy to see or spot, but you can see that they are starting to get separated from the place they should be. But we will fix that with the attribute that makes them rotate all around the original curve. Here I did a mistake and I defined this attribute with a math attribute instead of a vector math. So we are going to use Shift S. So if we check the content of this attribute in the viewer, you will see it now. The value, instead of a coordinate of 3 different values, this is just a single value. So with Shift S, we can switch the node and we can change it to vector instead. Now we can set this to vector. We use position here and we make the result position 1. And now we have position 1 with 3 different values for the coordinates. As I told you, each line is rotating along their original position, initial position. That's why we have this kind of offset here. And in order to fix this, we have to make them every single line rotate around the original curve. So now we define position 1 as our center of rotation, and we can see how every line goes correctly, even if we tilt this to the right place. Okay, so now we have to deal with the curve. We need to bend these cables. What I want to do is to create another point in the middle, in between the instances, and move it down depending on the distance they have to the instances. In order to do this, we need 2 different things. One, the distance, or a mask with the distance that the point has to the instances, and we also need to leave out of this mask the points that are attached to the posts. So that way they will stay in place when we make changes. To create this point in the middle, we will use a node called curve subdivide, and we are going to use this to add one cut in between the 2 points. And now we can create the mask that will give us the distance to the posts. We will use a proximity node. And now I want to know the distance between our geometry here. And as the target, we will use our cube, the one that it's making the T shape. So we plug it here. So now we have a result with the distance between our geometry and the cube, or in this case the faces of this cube. We can name this attribute as we want. I will use distance to make it easy to recognize. And this result makes the value of the one that is closer to the T lower, and the one that it's in the middle has a higher value, and it will increase if we move this further away. On the next step, I want to leave out of this mask the points that are close to the posts, and to do that we will use attribute compare, and I will compare my distance. Let's connect this so we can see what we are doing again. If we don't plug it, we don't see the list of attributes. So what we want to do here is to compare our distance with a float, a number. If we check here on the viewer our distance value, we can see that the closest points are at 0.020. So we are going to use a number that is slightly higher than that. So now we will compare our distance with 0.025, for example, and we are creating a mask that makes everything that it's higher than 0.25 in distance will be 1, and the rest will be 0. In this case, I will call this select. Now in this attribute, we only have the points that are in between instances. And you can corroborate this. Here we have a new boolean that only has the points of the middle selected. Now I want to keep my original distance value, but the ones that are close, that have a very little number, I want them to be 0. Instead of having this 0.020, they will be 0. So if we make any operation later, they will be multiplied by 0 or whatever, and they won't move. And that's exactly what I want. In this case, we can use attribute math, because we are just using a float here, not a vector. And I will multiply distance by my selection, and the result will be again distance, will replace distance. So if we check distance before we do this, we have this 0.020 value. And if we check this after the operation, you can see that they are 0 now. And if we multiply these or we use this as a factor, they won't get affected. Okay. Next node, we will use another math, multiply by a float. And for now, we will leave it at 1. This is just to have a multiplier of the distance, so we can change later at what distance these cables become more or less bent. Now we are going to define 2 different heights for this center point. One will be the highest point that this line will be. We don't want it to be straight like this. And one will be the lower point that these cables will reach. To do this, we will use an attribute vector math, 2 in this case. And I will say, take the original position that they have, vector. One will be, for example, -2. You could, if you want, expose this value and make it maybe the height multiplied by -1, but I will not explain things that we already saw. I want to keep this tutorial short. And here we will create something similar, but in this case, we will add to position vector, and in this case I used -0.1, and the results are pos1 and pos2. And now we are going to mix these 2 new positions, so we add an attribute mix. The factor will be an attribute distance, so depending on the distance they have to the posts, it will be closer to the -2 or the -0.1. So when we have more distance, we will be closer to this will be more tense, so we will be closer to -0.1 and closer to the -2. So we mix pos1 with pos2, not position 2, pos2. So more distance, closer to pos2, less distance, closer to pos1. And my result will be, for now, curve. We don't want to already replace position. Now, I don't want all of the cables to have the same exact height. We want a bit of variation, so we are going to use an attribute randomize. And we will add to the curve attribute that is like a temporary position in our case. In this case, we don't want to replace it, we want to add to this location, and I will add a random number between 0 and minus 0.3. If you want, you can expose also a seed, so you can change the heights of the cables here. And now we can do the final mix here. We will use mix. And in this case, we are going to use an attribute for the factor here. And the factor that we are going to use is the selection that we created. So in this case, we will affect only the ones that are in the middle, and the mix will be the position that they already have with the curve that we also created, and the result will be position. So we replace the actual position. And now we can connect everything we did here. We disconnect the other cable here, and we have a little problem here. I created this randomization with a float instead of a vector value, so we need to change this to vector, and now we have to adjust the values to what we wanted. We don't want to change the values on x and y, and we are only changing this value to minus 0.3. And we are also missing a clamp here to limit our factor from 0 to 1, because if our distance is higher than 1, we will have a multiplication of more than 1, and we don't want that. So we are adding this clamp, and the distance will never be higher than 1 or lower than 0. So we clamp distance, the result replaces distance, and we have a range of 0 to 1. I will show you what happens if we don't use this. Let's mute this node with M, and now if we move this, it continues to go indefinitely up. But if we clamp this, you can see that the maximum value that it can go, it's the one that we defined here. We also have our multiplier that we defined here, that it's multiplying by 1 at the moment. So this value will define how much distance you need to tense these cables. In my case, I used 0.5. You can do as you want. If we make this closer to 1, you will see that it will get tense at a closer distance. Okay, we are almost finished. Now we need to make a curve to mesh to give some volume to these cables. And we also need a profile for this curve, so we are going to use a curve circle in this case. In my case, I used 0.005 and a resolution of 6 in my case. So now we connect this to our profile. And as you can see, we have our setup working now. We can change our height. We have also our tilt control, also the seed. We can also control the height of our cables there. And when we enter edit mode, we can, with E, we can still extrude as many of these posts as we need. And now you can work on the details. I hope you have liked this tutorial. Remember to support the channel if you can. Thanks for watching, and see you in the next video. If you want to support this channel and keep it going, you will find the link to my Patreon account and my stores on the description of all my videos. Liking, subscribing, and commenting on the videos will also help me reach more people, so thank you in advance.